sine of 2 times x plus h. I'm going to put it in an extra set of parentheses just so it's really clear that that's still part of the sine function, or at least as clear as I can make it, minus the sine of 2x all over h. All right, so then we would do limit as h approaches 0. I'm going to distribute within this set of parentheses to clean it up a little bit. Sine 2x plus 2h minus the sine of 2x all over h. Once you make that move, it becomes like the problem that we did on the previous page, where we have a sum of two components within the sine function. So now it's just a matter of applying the appropriate identity. So the limit as h approaches 0 of sine of 2x cosine 2h plus cosine 2x sine 2h minus the sine of 2x all over h. So it has the same structure as all the stuff on the previous page. So we want to do something similar to what we did on the previous page also. So we want to group together any parts that would be factorable by a GCF. The cosine 2x sine 2h isn't really common to anything else. It's got the same ingredients, but if I group the middle term with either of the two outer terms, I'm not going to be able to pull out a GCF. But I will be able to pull out a GCF if I group these two together. So sine 2x cosine 2h minus sine of 2x. I'm going to put that over an h. Then we're going to have plus cosine 2x sine 2h also over h. All right, so we just have to make some minor adjustments here and we'll have it. Because, or at least looking at the black one here, I have sine 2h over just an h. I'd like that to be sine of 2h over 2h in order to meet the standards in the model. Right? So I'm going to multiply top and bottom by 2. And that's going to happen in both cases. All right, so you can distribute through the 2 if you want, or you just kind of leave it off. It really off on the side in the numerator, it really doesn't make a difference. But you do want to multiply it by the h on the bottom. All right, so I'm looking at limit as h approaches 0. I'm going to leave it out. And in fact, I'm going to do more than that. I have my GCF here. I'm going to pull that out and group it with the 2. So it's going to be 2 times the sine of 2x. And that'll be cosine 2h minus 1 over 2h. And then same idea for the other one. I'll put them together. The 2 along with the cosine. Let me get this out of here. So plus 2 cosine 2x multiplied by sine 2h over 2h. All right, so the first fraction goes to what? 0. The second one goes to what? 1. So we're looking at the limit as h approaches 0 of really just 2 cosine 2x. So that's going to give us a result of 2 cosine 2x. All right, now there's a shortcut in there. If you compare what you start with and what you end up with, you get the makings of that shortcut. So try number 4, go through the process, you'll see what the answer is there, and then you'll be able to determine, oh, this is the shortcut. So try that, and then complete the table. So between today and tomorrow, because we're down to the end. I'm going to write it as cosine 5x cosine 5h minus cosine 5x all over h. All right, so I'm taking the first term and the last one and putting them together because those are the ones that have the common cosine 5x. All right. So then from that, I'm going to subtract off everything else basically. So sine 5x, sine 5h, all over h. All right, and so in this process, you should be able to apply one of our rules. But if you don't see it right away, that's okay, because if you continue the factoring, it'll become more and more obvious. So like in the next step, I might, instead of trying to use a shortcut, I might actually just show the cosine of 5x being factored out, giving us cosine 5h minus 1 over h. And then minus sine 5x, make that its own coefficient of the fraction sine 5h over h. All right, once you get to this step, you're pretty much done, because if you know your limit rules, the really important limit rules, limit, I'll just use a's. A approaches 0 of sine a over a is equal to 1. And then the other one, limit as a approaches 0 of 1 minus cosine a over a is equal to 0. And the corollaries to that, so the reverse, we could do the cosine first. We could write it as cosine a minus 1 over a equals 0. And this one we can adjust and say a known x, a over the sine of a. So basically any variation of those would be fine, right? So if you know about those relationships, you're in good shape. So that's telling me that whatever is contained within sine needs to match my denominator, whatever is contained within cosine needs to match my denominator. So I'm going to do an adjustment. I'm going to correct for it on the fly. So I'm going to multiply this by 5 on the bottom, and I'll just multiply by 5 here to offset it. Top and bottom of the fraction by 5, it's the same as multiplying by 1. I'm not changing anything. All right, I'll do the same thing here. Bottom by 5, top by 5. All right. So this would cancel to 0. This would cancel to 1. And so out of all this mess, the only thing I'm left with is a negative 5 times the sine of 5x. All right, so basically the last thing here. And that would be my derivative f prime. Oh, okay. That's the answer. All right, so we have to try to come up with a relationship out of this. The first one was sine of 2x. And we came up with 2 times the cosine of 2x as a result. Right, so let's just kind of play this out logically. If I take the derivative of just sine of x, I would get cosine of x. If I take the derivative of sine of 2x, I get 2 cosine 2x. So then the question would be, and I guess I'll put this on the big board. What if I had something like the derivative of the sine of ax, where a is some constant multiple. So a is just some number. What would my derivative be? A cosine ax. All right. So along those lines, we have the derivative of cosine of x is equal to negative sine of x. We just discovered that the derivative of cosine of 5x is the same as negative 5 sine 5x. So I'll do the same thing. I'll come up with, in general terms, the sine of cosine, some constant multiple of x. The derivative of that would be what? Close. Negative a sine ax. So now we have some rules. But we only got those rules because we investigated through the limiting process. Right? You do enough of them, you pick up on these relationships. And then a natural question, a follow-up to it would be like, well, so how would this play out for like tangent and cosecant and things like that? That's the next page, so we'll get there. But now we can figure out all of these problems with really not much effort. So what's the first one going to be? 3 cosine 3x. What'd you say, negative 7?
Yeah,
Sine 7x. Next one's mixed, but it's still not too bad. Now what does the negative x cubed become? Minus 3x squared. And the 2? 0. Derivative of a constant is equal to 0. All right, so the negative x squared, we applied that power rule that we talked about last week. So it's kind of a mixing and matching here. All right. For the last one, the cosine 4x becomes what?
Negative 4 sine 4x.
Exactly. The next piece is a little trickier because we have a coefficient. What are we going to get for that one? 2 cosine 2x for just the sine 2x times the negative 3.
So it's negative 6 cosine 2x.
Exactly. And the last piece there, plus what? 8x cubed. Now I'm not going to make you do it, but you can just imagine, for especially the last two, how crazy that would be if you had to do it with the limit definition. A little f of x minus f of a, or a little f of x plus h kind of business. You'd be at that for a while, I think. And I don't think it would be fun. So I'll just